Hello student, welcome to the one more session of ARM. In this session you are going to learn interrupts or exception. As I told in my previous video, the ARM7 makes use of 7 interrupts and each 7 modes. That means ARM7 works in 7 different operating modes. There are 7 interrupts and these 7 interrupt takes you to 5 different operating modes, because the 2 other modes do not want any interrupt. So now what are those modes? So what are those 7 operating modes? Let me write here. The 7 operating modes are, the 7 different operating modes are: one is supervisor, one is supervisor, second one is user mode, third one is system mode, third one is a system mode, fourth one is IRQ mode, fifth one is fast interrupt request FIQ mode, sixth one is undefined mode, and seventh one is abort mode. So both undefined and abort are error modes, error reporting modes. So 90% of the time your ARM7 processor or your like your mobile system will be in the user mode. So from user mode to invoke the user mode, you don't need any interrupt. For example, when you restart your system like mobile phone or ARM7 based processor, first it goes into supervisor mode and it will load the operating system. Once the operating system is loaded, it will take you into the user mode, and 90% of this time it will remain in the user mode. So if you invoke system related function, it will go to system mode. So to go to user mode and system mode, it don't need any type of interrupt. So other than that, to go to supervisor mode, IRQ mode, FIQ mode, undefined mode, abort mode, it need interrupts. Okay, now so the 7 interrupts are reset, undefined instruction, software interrupt, prefetch abort, data abort, and IRQ and FIQ. One more is reserved for to view the compatibility with the previous version of ARM7. So a reset interrupt will take you to the supervisor mode, and undefined will take you to the undefined mode. Software interrupt will it is a shortened representation here. It will take you to the supervisor mode. Free fetch abort and data abort, it will take you to the abort mode. Then interrupt request, it will take you to IRQ mode, and fast interrupt request, it will take you to FIQ mode. These are the address of the ISR routine. So all interrupts in ARM7 are vector based interrupt. Vector based interrupt means all interrupt has got fixed address. So here this is the lower address and it is the higher address. These address will be set based on the position of ROM and RAM in the in ARM based system. We will come to that later. So let me make once again clear about this, the relationship between this interrupt and different modes. You know there are 7 interrupts, but these 7 interrupt take you to 5 different modes. So reset and software interrupt, it will take you to supervisor mode. Other than that, undefined will take you to undefined mode. There is a mode called as undefined. Other than that, free fetch and data abort, it will take you to abort mode. IRQ will take you to IRQ mode, and FIQ will take you to FIQ mode. You have to remember here, both user and system mode doesn't require or invoked with any type of interrupt. So let's start with first reset mode. What is the reset mode? So normally ARM7, there is ARM7 treat reset as a interrupt. Normally other processor treat reset as a signal. So when you reset your mobile phone or ARM processor, first it will invoke the program called as a BIOS. BIOS is stored in a ROM. The program called as a BIOS. BIOS is nothing basic input output system. That will take around 30 to 40 seconds and it will load the operating system from the primary memory, from the secondary memory to the primary memory, and after that it will initialize the various settings in the operating system, and then after that control will be passed to the user, and that mode is called as a user mode. So to load the operating system it needs highest privilege, so of course that makes your system to be in supervisor mode. Understood? So reset takes you to the supervisor mode. One more is a software interrupt. So suppose you want to execute certain important related functions, like you want to install certain app that requires more privilege. So installing app in a sense like you are going to select the app from the app store and you will hit the install button that will make changes in the root of the system, root of the operating system that needs some supervisor privilege. For that you need to call software interrupt instruction, SW instruction followed by number, that will take you to from user mode to supervisor mode, where it will do the necessary changes. Once the installation is done, it will once the installation is done, you will come into normal mode, that is user mode. Other than that, we have one more mode that is called as undefined instruction, that will take you to undefined mode. When there is a undefined instruction that opcode cannot be analyzed by ARM7, then it will take you to undefined mode, where it will kill the application and you will be taken back to original user mode, that is called undefined mode. Then we have two more, that is something called as a pre-fetch abort and data abort. So pre-fetch abort and data abort is you are as a user, you have got access to the user program and user data. Suppose if you want to try to make access to the system program or system data, then it will take you to abort mode. Suppose you are going to access system program, that is you are accessing system program means pre-fetching instruction, then it is called as a pre-fetch abort, and during the pre-fetch abort it will take you to pre-fetch abort mode, where it will kill the application and it will take you to back to the original mode, that is user mode. When you are going to access system data, then it will take you to the abort mode, that is called data abort mode, where it will kill the application and it will take you back to the original mode called user mode, that is called as a data abort mode. Other than that, we have something called as IRQ mode and FIQ mode. IRQ mode means in ARM7 there are two pins, like one is interrupt request pin and fast interrupt request pin. If there is an interrupt request or interrupt request pin, then it will take you to IRQ mode, and if there is a fast interrupt request, then it will take you to fast interrupt request mode. Fast interrupt request modes are faster because it has got a separate set of registers which doesn't require of copying register related information to stack when it moves to ISR. So now we will see this column. What is this column? This column is nothing but the address. So whenever the interrupt comes, you know, whenever the interrupt comes, this is the procedure. Whenever the interrupt comes, it goes to, whenever the interrupt in ARM processor, whenever the interrupt comes, it goes to ISR. It goes to ISR, execute the ISR, and it will return back from there to the to the next instruction has to be executed. So this ISR has got, in ARM7, this ISR has got fixed address. So if the ISR has got fixed address, such type of ISR are called as a vectored interrupt. In ARM7, all the interrupts are vectored interrupt. Now we have to see when the interrupt request comes, it will go to ISR. That time, what changes, what pre-request or what changes has to be taken in the register. First of all, before going to ISR, when the interrupt comes, before going to ISR, CPSR has to be copied to SPSR. We know what is a CPSR. CPSR is nothing but a current program status register which we want when we return back from the ISR. So that has to be copied to SPSR. SPSR is nothing but a stored program status register. So current program status registers contains flag information, then mode informations and IR key information and FI key information. All these informations will be copied into SPSR. Then second, after that mode bit needs to be changed. So once after copying CPSR to SPSR, mode bits needs to be changed depending on the different types of mode and interrupt. After that, it need to activate new set of register. You know, when it moves from when it gets interrupt and it moves to the ISR, it will jump to different operating mode. In different operating mode, it will have different set of register. We know link register, then SPSR register, then stack pointer register. It will get new set of register. All these new set of register has to be activated. Then make the T bit in CPSR to be 0. What is the meaning of T bit? What is the meaning of T bit? We know T bit indicates a thumb state. If the T bit is 1, so if the T bit is 1, the processor is in thumb state. If the T bit is 0, the processor in normal state. In thumb state, the processor will execute 16-bit instruction. In the normal state, the processor will execute 32-bit instruction. Now as ARM7, it may execute 16-bit or 32-bit instructions. It may execute 32-bit instruction when in the normal stage, and depending on the situation, it may execute 16-bit instruction. But whenever ISR comes, we assume ISR all the instructions will be in normal state. So you need to do the changes to the thumb bit 0. Thumb bit 0 means 32-bit. Once again, I will repeat why you are going to make thumb bit 0, because you need to assume that in ISR, inside the ISR, all the instructions are in 32-bit. It is not in a 16-bit. After that, program counter will be copied, the address of the program counter, like the current address of the program counter, will be copied to link register. Now the program counter is loaded with the ISR address. The program counter will be loaded with the ISR address. After execution of the ISR, the reverse process will take place. You can see here the reverse process. These are the reverse process. What is the reverse process? The reverse process is SPSR will be copied to CPSR, so that your original flag information, as soon as when it returns from the ISR, your original flag information will be retrieved. Then return address from the LR link register will be copied to the program counter. Now the program counter has got the next address, like address of the next instruction to be executed. Then when it returns to the original state, like user mode, you need to reactivate the previous registers. This process will take place once it returns from the ISR. Now here you know these are the, so students, there are two type of address: lower address and higher address. These addresses are given to the ISR routine, and this is a fixed address. That's why the ISR routines are called as vectored address or vectored interrupt. Like those ISR routine contains fixed address. For example, when the reset interrupt comes, then control will be taken into this address, like 0000. The next address will be 0004. The next address will be 008. There will be a gap of 4 bytes. Now the question comes, why the gap of 4 bytes? Or within 4 bytes, can you write the entire ISR? Now you think like the ISR program of bootloader, it will be more than 4 bytes. You cannot exactly predict the program size, in the sense like it may be, it will be very big, and it depends on the program. That's why, so ISR is not written here. Here 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 it contains the address of the ISR. So ISR will be somewhere else in the memory. So here it will be the address of the ISR. So when the reset interrupt comes, the control will be transferred to here, and from here it will take one more branch instruction to jump to the ISR address. So now that branch instruction size, you know, all the ARM instructions are 4 bytes. That's why that's why this 4 bytes gap is there. Like whenever interrupt comes, it will come to this address, and this address contains one more branch instruction that will take you to the ISR. Similarly, whenever the interrupt request, past interrupt request comes, it will come to this address, and from here it will move to the ISR. So this address contains the address of the ISR, not ISR routine. So we have two addresses here, lower address and higher address. So lower address and higher address, you can either use lower address or higher address depending on the ROM. Whether your ROM is placed with the higher address or ROM is placed with the lower address. You know there are two types of memory, RAM and ROM. RAM is called as volatile and ROM is called as non-volatile. Non-volatile in the sense like information will be saved in the case of power loss. So ISR routine should be in the memory. ISR routine should be in the ROM. So depending on the placement of the ROM in your board, you can take either lower address or higher address. So this is the information related to the interrupt in the ARM7. How the interrupt will be handled in ARM7. Thank you for your cooperation. Thank you.